Okay, today is May 15th, and we're going to do sum and difference identities, and it's going to be the first day of it, okay? So these are called sum and difference identities for cosine, sine, and tangent, okay? So before we had calculators, all right, we knew how to find, because of special right triangles, like sine of 7 pi over 6, and we knew how to do all of those special right triangles. But is there a way to do it? What if you have an angle that's not a special right triangle, right? How can you find sine of that or cosine of that or tangent or secant or cosecant, right? So these are three of them that we can use, and so we can find the exact value of other angles other than special right triangles, but we need these, okay? And we still can't do all of them, but this adds to how many more we can do, okay? So alpha and beta are just two different angles, okay? And this is adding right here, okay? So if we're taking cosine of two angles that we're adding together, okay, then that's equivalent. This is an identity. We're not gonna prove these identities, because I will be honest with you, it would take about an hour just to prove all of these, okay? And it's just not worth the time, okay? There's just not much benefit in just doing that, okay? I used to do it, okay? But it just takes so much time, all right? So right here, cosine of alpha plus or minus beta, then that's equivalent to the cosine of this angle alpha and then times cosine of this angle beta, all right? But notice, this matters, right? This is plus and this one's minus on top, right? And there's a reason. It's just not random. When it's addition here, this has to be subtraction. But if this was subtraction, then this would have to be addition. So they match up, like whatever operation you're doing here, you have to match it with here, okay? So if we're adding, then we'd have to subtract here, okay? And it'd be sine of angle alpha and sine of angle beta, okay? If we were subtracting, it'd be cosine alpha, cosine beta, plus sine of angle alpha, sine of angle beta, okay? Sine of alpha plus or minus beta would be sine alpha, cosine beta, plus or minus. So if this one's adding, you're gonna add this one. If this one's subtracting, you're gonna subtract this one, okay? And then cosine alpha, sine beta, okay? So what happens is the trig functions, you notice the trig functions switch, okay? Sine, cosine, cosine, sine, right? Okay. This one is cosine, cosine, sine, sine. So that I always tell people that to help, because usually I test you on this and you have to have these memorized. Obviously this year I can't do that, all right? But I still think it's good to know what these are. So for cosine, it's gonna be cosine, cosine, and sine, sine, right? And for sine, it's sine, cosine, cosine, sine with the same angles, okay? All right. And then tan of alpha plus or minus beta is tan of alpha plus or minus tan beta. So if this one's adding the numerator, we're going to be adding them together. If we're subtracting, okay, then we're going to be subtracting the numerator, right? And then the denominator would just be 1 minus plus tan alpha tan beta. So this one's going to be the opposite of what we're doing here, okay? Now, this is going to be really important, okay? Notice these alphas and betas we're going to have to take the cosine of alpha or the cosine of beta or the sine of alpha or the sine of beta, right? Okay, or the tan of alpha or tan of beta, right? So alpha and beta have to be angles that we can find sine and cosine and tangent of, okay? So it's got to produce us a special right triangle, okay? So our alphas and our betas, okay? So I'm going to write this in red, okay? Alpha and beta need to be multiples, okay, of pi, because any multiple of pi, like 3 pi or 4 pi or 5 pi, we can find sine, cosine, and tangent of that, right? Okay, pi over 2, because we can do that. We can find angles. We can find the trig functions when the angles some multiple of pi over 2. So like pi over 2, 3 pi over 2, 5 pi over 2. I'm not saying 4 pi over 2 because that would just reduce to a multiple of pi. Okay. Multiples of pi over 3, because those will give us special right triangles. Pi over 4, because those will give us special right triangles. And then also pi over 6, okay, because that will give us a special right triangle, okay? So let's just jump in here and do this, okay? So sine of negative 5 pi over 12, okay? So I need to break this angle into, okay, two angles that reduce to give you one of these. Okay, so I'm gonna try some, and we'll see. Okay, so I'm gonna do it from a negative angle minus another angle. Okay, so let's do it like this. Okay, so let's try this. Sine of, let's just jump in here and try it. Negative pi over 12, whoops, pi over 12, not pi over 4. So negative pi over 12 minus 4 pi over 12, okay? Because that is equivalent to sine of negative 5 pi over 12, right? But let me make this a little bit clearer, okay? But there's a problem with this. This one's good because this would reduce to minus pi over 3. And so my beta would be pi over 3. That'd be good. This one doesn't reduce, okay? So I can't use this one, okay? All right? So I'm going to up this one by 1. Okay, so this one doesn't work. Okay, how about sine of negative 2 pi over 12? But then I'd have to subtract 3 pi over 12, wouldn't I? Because that would give you negative 5 pi over 12. Okay, now do these reduce? Yeah, because this one becomes negative pi over 6, right? And then we have a minus, and this one becomes pi over 4. Now, there's always going to be more than one option that would work. Okay, so I'm going to show you, but at the end, you would get the same answer. Okay, so you could decompose this a lot of ways, and they reduce to one of these multiples. Okay, so I want to make that really clear. There isn't just one way, okay, that you can break this up. Okay. All right. So let's jump in here. So let me just give you an example of one of them. Okay. You could have also done negative 8 pi over 12. Okay. And negative 8 pi over 12. Let me just write it. Sine of negative 8 pi over 12. But I would have to add 3 pi over 12, right? So in this case, my alpha would be, and this one reduces, right? Because they're both divisible by 4. My alpha would be negative 2 pi over 3. And I'd be adding, and my beta angle would be pi over 4. Okay? So if somebody, like, if you weren't watching the notes and you knew how to do this, okay, and you did this and somebody else did this one, right? You're both going to get the same answer at the end, okay? At the very end, okay? So I'm going to do this one, all right? So we have sine of negative, let me go ahead and write sine of negative 5 pi over 12. Okay, and that's going to equal sine of negative 2 pi over 12 minus 3 pi over 12. Because if I combine those, it gives me the negative 5 pi over 12, right? But now these reduce, right? So sine, this becomes sine of negative pi over 6 minus pi over 4. Okay, so in this instance, my alpha is negative pi over 6, and my beta would be equal to pi over 4, and I'm subtracting the two angles, right? Because this is subtraction. Okay, I'm going to slide this up a little bit. Okay, so from up here, okay, we're going to do sine. This is going to equal sine of my angle alpha, which is negative pi over 6, cosine of pi over 4. Since I'm subtracting, right? Since I'm subtracting, I'm going to need to subtract this one, right? So minus, and then the trig function switch. Okay, so this one's going to be cosine of alpha, which is negative pi over 6, sine of beta, which would be pi over 4. Okay, so now it's, you guys, it's just a matter of figuring these out. Okay, so sine of negative pi over 6. So I got to draw a diagram for the negative pi over 6 angle. That would put me in the fourth quadrant, right? Because the negative angle, right? My reference angle here would be pi over 6. This y would be negative 1. My r would be 2. This would be positive square root of 3. Okay, For pi over 4, that's in the first quadrant, right? So this is angle pi over 4. I know from pi over 4, this would be 1, the vertical leg would be 1, this horizontal leg would be positive 1, and the hypotenuse or radius is the square root of 2. Okay? Hopefully this isn't that bad, okay? All right, so then this would be equal to, okay, so sine of negative pi over 6. Sine of negative pi over 6, sine of this negative pi over 6 would be, it's your y over your r, right? So it's negative 1 over 2. So I'm just going to put this in parentheses. Negative 1 over 2 times, what's cosine of pi over 4? Well, cosine of pi over 4 would be this x, which is 1 over the square root of 2. Okay, and then we have the minus right here, right? So I'm going to write minus. And then cosine of negative pi over 6. So cosine of negative pi over 6 would be square root of 3 over 2. And then sine of pi over 4. That'd be this one right here over the square root of 2. Okay, so now from here you have a couple options, okay? You could go ahead and multiply and you'd have a common denominator, okay? I think it's easier if we simplify these two square roots first, okay? So what does 1 over the square root of 2 simplify? We should know this like automatically, right, from the inverse trig functions. 1 over the square root of 2 is equivalent to square root of 2 over 2. So I just think it's easier if we do that first. So negative 1/2 times the square root of 2 over 2 minus the square root of 3 over 2 times the square root of 2 over 2. Okay, so this would become negative square root of 2 over 4 minus the square root of 6 over 4. And we have a common denominator, right? So then this becomes negative square root of 2 minus the square root of 6 all over 4. That is the exact sine ratio for negative 5 pi over 12. It's an ugly number, right? Because there's two square roots in it, okay? But that's it. That's the answer to this, okay? And that's how the Greeks years ago, okay, did this. And they needed all of this trigonometry. Really, I'm going to tell you, they needed all this trigonometry to do astronomy, okay? That's where they used a lot of this trig, okay? The Greeks and really the Persians, okay? All right, guys, let's go to the next example. It's just going to be using these formulas. Okay, for this one, it's the same idea, but it's going to be cosine, but we're in degrees. And I think degrees is harder to do, okay? So we need to break this up, okay, into, now we said multiples of pi, right? So we need multiples of 180 degrees, 90 degrees, 30 degrees, 45 degrees, or 60 degrees. Okay, so what happens, okay, if I'm thinking, because it ends in 5, what if we take 45 away from this? Okay, so that would give us 240 degrees, right? And 240 degrees is a multiple of 60, okay? So that's what I'm going to do, okay? So I'm going to break this up into 240 degrees, okay, plus 45 degrees. So cosine of 285 degrees is equal to cosine of 45 degrees plus 240 degrees, because that would still give you 285 degrees, right? This right here, okay, just so you know, this is 4 60-degree angles, right? And this is one 45-degree angle. Okay, so four 60-degree angles is a multiple of 60 degrees, right? Now, are there other alternatives to this? Okay, yeah, because you could actually do 60 degrees. I'm thinking of other ways. Okay, 60 degrees, take 60 degrees away from this, and you have 225 degrees. 225 degrees is a multiple of 45 degrees. Okay, all right. That would be 1, 2, 3, 4, 5. It'd be 5 45s, okay? 5 45s is 225 degrees plus the 60 degrees, okay? So that my point of that is there's more than one way to do this, okay? more than one way. All right. So in this case, my alpha is equal to 45 degrees and my beta is equal to 240 degrees. And I am adding, right? So this is equal to cosine of 45 degrees, cosine of 240 degrees, minus, because it's the opposite for cosine, right? If you're adding here, you're going to be subtracting here, okay? So cosine of alpha, cosine of beta, minus sine of alpha, which is 45 degrees, sine of 240 degrees. Okay, so I'm going to draw a 45 degree angle diagram and a 240 degree angle diagram. So 45 degree angles is, this would be 45 degrees, and the two legs would both be +1, and this hypotenuse would be square root of 2. 240 degrees, okay? So that's more than 180, but it's less than 270, right? So it's in the third quadrant. Okay, so I know this is a 240 degree angle. Okay, that is 60 degrees past 180, right? So always opposite the 60 is square root of 3, but we're going down, right? We're below, so this is negative square root of 3. We're going left, so this is -1, and this is 2. This is not drawn to scale at all, and it doesn't have to be, okay? It's just putting the diagrams together and putting the numbers in the right spot and then pulling them off to get the right trig function ratio, okay? So cosine of 45 degrees would be this one over the square root of 2. If you went to write, just directly writing square root of 2 over 2, that'd be fine. Cosine of 240 degrees would be this -1 over 2. And then minus, right, because it's minus. And then sine of 45 degrees would be this one over the square root of 2. Again, you could write square root of 2 over 2 times, okay, sine of 240 degrees. So sine of 240 degrees would be this negative square root of 3 over 2. Okay, so this I'm going to rewrite as square root of 2 over 2 times -1 over the square root of 2 minus the square root of 2 over 2 times negative square root of 3 over 2. Okay, so this one would be negative square root of 2 over 4. And then these two we multiply and we get a negative, right? But we're subtracting, so it's actually going to be positive square root of 6 over 4. And that would be, I would probably write the square root of 6 first. So square root of 6 minus the square root of 2 all over 4. And that's the answer to this one. Okay, so if you type, well, let's, here, I'm going to pull my calculator out just so you don't think I'm, like, how do you know I'm not making all this stuff up, right? Like, how do I know? Okay, so, okay, I guess I have to switch to degrees because this is in degrees. Okay, so I'm going to press my mode. Okay, I'm going to switch over to degrees. Okay, so let's look, cosine of 285. So nowadays we just have calculators that we can just do this with, right? Okay, so there it is, okay? Watch what happens when I put this in. Okay, so alpha, fraction bar, square root of 6, and then outside the fraction bar is minus, and then square root of 2 over 4. Look what happens. It's the same answer, huh? Is that wild? And the Greeks knew this years, well, before the Greeks even. Okay, the Persians. Okay, Mesopotamia and all that kind of stuff. All right. Kind of amazing. They knew all this back then, right? Okay. So yeah, see, they give you the same value, right? Okay. All right. We need, okay, I'm going to be totally honest with you. These sum and difference identities really don't come up that much in calculus. It's some identities that come from knowing those. Okay, so it's some identities that come under those that we get from knowing those sum and difference. So the sum and difference are important in getting other things. They're not that important in and of themselves. Okay, just to be honest. Okay. All right, so let's go to the next example. Okay, for this example 3, it's kind of doing the reverse of what we've been doing, okay? So sine, cosine, and then minus, right? Okay, so if we start out with sine of 7 pi over 18, and then cosine of 5 pi over 36, and then minus cosine of 7 pi over 18, sine of 5 pi over 36. This is just an exercise, really an exercise in just you like understanding where everything goes in the formula, okay? This isn't that hard of a problem, okay? So this comes from the sum and difference identity for sine, okay? So we know this is equal to sine of, okay, and my alpha is the 7 pi over 18. Okay, so for sine, it matches up, okay? So whatever we're doing here, we're also doing in between the two angles, alpha and beta, okay? All right, so since this is subtraction, we're gonna have to subtract. Well, what's my beta angle? Well, this was alpha, right? And this one's beta, right? So we have 7 pi over 18 minus 5 pi over 36. Okay, so I want to find the exact value of this, right? And so I can do that, all right? What I'm going to need to do is I'm going to need to get a common denominator, okay? 18 times 2 is 36, so I just need to multiply top and bottom by 2. So this becomes sine of 14 pi over 36 minus 5 pi over 36, okay? This becomes sine of, and this would be 9 pi over 36. And 9 pi over 36 reduces, okay? This becomes sine of pi over 4. So we could draw a little diagram for pi over 4, right? That's in the first quadrant. Okay, pi over 4 is the angle of rotation. That's also the reference angle in the first quadrant. So this is 1, and this is the square root of 2. I'm going to tell you, you know what's so funny is like I'm doing Calc BC stuff right now, okay? And I just got done doing a lesson, and we have to do the same thing in Calc BC, all right? We have to draw diagrams. It has to do with vectors, but we're doing the same thing. It's exactly the same thing, okay? Okay, so sine is this one right here, this y coordinate, right, over the square root of 2. So this is equal to 1 over the square root of 2, or simplified, that would be the square root of 2 over 2. And I want you to simplify, okay? You need to know that these two are equivalent, okay? And you do it enough that you just know it's equivalent, okay? All right, guys, let's go to the next problem. This one's a little bit easier to recognize because there's only one formula for tangent, right? There's only one of them that deals with tangent, okay? So this is the reverse of like what we just did, okay, but with tangent. And I wanted to show you that. Okay, so tan of 29 pi over 18 plus tan of 2 pi over 9 all over 1 minus tan of 29 pi over 18 tan of 2 pi over 9, because we're trying to figure out what this is, right? So we should write this, okay? What is this equivalent of, okay? So it's going to be a single tangent, right? And so in this case, my alpha is 29 pi over 18. Okay, and what I have to decide is, am I adding these or am I subtracting them, right? And if you look, okay, in the numerator, okay, in the numerator, I'm adding, right? So if we're adding in the numerator, that would mean that we have to add the two angles alpha and beta, okay? So we're going to add the beta angle, which is this 2 pi over 9. Okay? So now what we have to do is we need to get a common denominator, right? So we need to multiply top and bottom by 2. So this would be tan of 29 pi over 18 plus 4 pi over 18. That becomes tan of, and this would be 33 pi over 18. Okay. And they're both divisible by 3, right? Okay, so that'd be tan of 11 pi over 6. Okay, so we got to draw a diagram for 11 pi over 6, right? So 11 pi over 6. Okay, so this would be 6 pi over 6, right? Right here on the negative x-axis, that'd be 6 pi over 6. Keep going, this would be 12 pi over 6, but that's too much, right? So I need to back off of pi over 6. So it's in the fourth quadrant. Okay, so this would be the angle 11 pi over 6. That would give me a reference angle of pi over 6. Okay, and if that reference angle is pi over 6, the side opposite has to be 1, but since we're going down, that would have to be negative 1. And we're going to the right, so that has to be positive, and that would be the square root of 3, and this would be 2. Okay, so this would be equivalent to tangent, which is the y over the x, so that'd be negative 1 over the square root of 3. Perfectly good answer. It is a correct answer, but it's not the best answer. So we need to multiply top and bottom by the square root of 3, and that would give you negative square root of 3 over 3. And that's the correct answer and the best answer. Okay. All right, you guys. So that's sum and difference trig identities. You guys, we just have 5 more days. That's it. 5 more lessons and we're done. We're done for the year. Okay. Right. I'm kind of sad. Well, no, I'm not. We all need a break from this, huh? Okay. All right, you guys, let me get the assignment sheet and we'll talk. Okay, guys, so today was the first day of sum and difference identities. We have one more day of that. It's these double angles and half angles that's why we need this, okay? We need these to come up with these. These double angles happen in calculus, okay? So what I want you to do is worksheet TEI 6, okay? That's what I'm assigning today. It won't be due, so today's Friday, it won't be due till Tuesday, okay? All right. And if you guys need a little bit, a few days, into the next week, like everything's, if you're turning everything in digitally, okay, through Google Classroom, okay, you're fine. If you get some things late, I'm going to be doing grades and all that all the way up into the first few days of June. So I will if you catch up, you're fine. Okay, you're fine. Don't worry too much about getting stuff to me late. Okay, please don't worry. All right. Okay, so finish this worksheet TEI 6. Okay, and that will be it. All right. See ya. Take care.